Alright, today's date is Wednesday, December 4th, 2019, 12/4/19. We are on lesson 3-2, determining congruent triangles. We are right here.
Wow!
We have 2 lessons until our test. Our objective for the day is, Gunnar?
Discover which propositions prove congruent triangles and use them to prove triangles are congruent.
There it is. Question, Andres.
I don't have it.
You may grab a pencil. Should I start a board of shame like Mr. Brown?
Yes, that'd be a great idea.
But after this, not right now. But
Alright, board of shame. What does he do? Does everyone be like, ooh? Or
Minecraft on my mind. You have to sing Minecraft on my mind.
No, it just tells you to be shamed.
No,
everyone shame upon Andres.
Shame.
No, you made that rule right when I got the pencil.
So this is an unusual lesson in the fact that we're mostly doing everything on our own. I wanted to try this out where I don't just give it to you because I feel like that's too easy and you're just going to forget it. If you discover it for yourself, the theory is you will remember it longer and better. It might fail horribly, but I'm hoping that you guys will try to do this the best of your ability. This is posted on Google Classroom already. If I go to this link, it's already up here, you will see something like this. When you go to this lesson on Google Classroom, you will see each of these. Double angle exploration, angle, angle, side, angle, side, angle, side, side, angle, side, angle, side, 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 side. So you start with angle, angle, and then you come back here for angle, angle. Again, the A means angle. You can write this down on your notes if you want. A equals angle. And S means side, and it just refers to the order of things that are congruent in the triangle. So this is saying I have an angle and an angle that are congruent in both of the triangles. This says I have an angle and a side, they're all adjacent to each other in both triangles, and they're all congruent. So if I just have 2 congruent angles in a row and then a side that's congruent, does that automatically prove that the triangles are congruent? And eventually you're going to solve all these and figure out. You're just going to answer yes or no or something like that. You're going to draw a picture like, oh, if I just do angle, angle, I could have something that looks like that or something. So you're going to draw a picture, you're going to answer yes or no over here, and you're going to do the exploration. So let me do angle, angle with you to give you a taste of what it's like. So before I do that, I want you guys to be able to play with me. So go and open up your laptops and get to this page. We're going to do the angle, angle exploration right now. All right, so now that everyone is there, I want you guys to drag these triangles around. Click on every possible thing and try to drag it around. The goal is, can you make it so that these 2 triangles are not congruent? So I want to try to make them not congruent. That's the goal. If you can't, then the answer over here is, well, if I come back to my notes, the answer is, okay, well, they're not congruent because I was able to make them not congruent. So if I drag these around, it's like, oh, well, obviously, I think these 2 triangles are not congruent. What do you guys think? Can you see my picture? I don't think these triangles are congruent. One is very much larger than the other. But you can move around things. You can say, I twist them around, I do whatever. Some of these don't move because they're locked into position by angle-angle theorem. But just angle-angle does not guarantee any side length is true. So by dragging C prime here, and I can drag B as well, you can do whatever you want. You can drag all of these around. But by dragging C prime, I can make this a much, much tinier triangle. I can make this triangle ginormous, and I can make C prime really, really tiny, tiny. You can see that these triangles are clearly not congruent, which means I come back over to my notes and I say, okay, so the picture of them not being congruent, well, this is one possibility that could happen. I could have a tiny little triangle and a giant big triangle, even though these 2 angles here, and it's really, I'm going to have to zoom in here because I made that triangle way too small, even though those angles here are congruent, angle-angle theorem, they're still not the same. So the answer here is no. Just because I have 2 angles that are congruent, that does not automatically prove that the 2 triangles are congruent. Let me do one more with you, and then I'll let you go off onto your own. Because eventually these get harder and harder. So that's what I'm going to write in my notes, and I'm coming back, and I'm going to go on to the next one. You come up here to the arrow on the top and just click right. Now I'm going to do, and it says up here, angle, angle, side exploration. Angle, angle, side. So it says that these 2 angles, A prime and B prime, are fixed. So A prime and B prime, you can see that this angle and this angle are congruent. A prime and A are the same angle. B prime and B are the same angle. All I can change is I can drag this around. I can make C, I can't change C. What can I drag? Can I drag? Oh, I can make this one longer. Can I make this one longer? No. Can I drag this one around? Oh, I can drag this one around. Okay. So make a triangle such that this point ends at the same point. So make sure that you have two triangles. And now move them around. So just on this first look, we can see, once you get to that position, if I look up here, I see, okay, all of the angles and all of the sides have to be congruent. I'll repeat that because it's important. Make sure you're listening to the statement. All of the angles, all three angles and all three sides must be congruent for the triangles to be congruent. I can check. 7.9, 7.9. Well, AC and A prime, C prime, those line segments are congruent. CB is 6.3, C prime, B prime is 6.3. AB is 6.8, A prime, B prime is 6.8. All of the angles are also congruent. Therefore, I can conclude that these two triangles are congruent. But I'm not done. I have to play around with it. Maybe they're not congruent if I do something special. So I have to play around and say, okay, what happens if I make this angle over here? Okay, that's not changing anything. What happens if I move A all the way over here? Okay, that's not changing. What if I move C over here? Nothing is going to make these triangles not congruent. Nothing that I do. Twisting this angle, no matter what I do, this is our first theorem that will prove that triangles are congruent, no matter what I do. So I'm going to come back over here and say, okay, if I have a triangle that looks like this, that same triangle will happen. If I have an angle, and a side, if I have an angle, and a side, yes. This one, maybe circle it, somehow let yourself know, this is now a theorem I'm going to keep in my back pocket, I'm going to keep in my Batman tool belt, whatever your analogy is. I need to memorize angle, side. That does work. For the rest of, well, I guess we only have 2 more weeks left, but for the rest of the semester, angle, side automatically proves that these two triangles are congruent. If these two angles are the same, these two angles are the same, and this side is the same. Notice that it goes around in a circle. Angle, then side. If angle, side is met by the definition of angle, side theorem, those two triangles must be congruent. This is what I'm going to have you guys do for angle, side, angle, which if you spell it backwards is a funny little word, right? And then side, and then side. Each and every one of these, I need a picture of them either being true with the correct angle, side. So angle, side, angle, you're going to have an angle, then a side, then an angle that are congruent, and say yes or no whether or not those two triangles are congruent. I will be walking around the room helping you guys. Good luck. All right, so for angle, side, angle, we should have discovered, was it a yes or a no? Everyone shout it out. Yes. All right, and then angle, side, angle means I have two triangles, and I really just want you to make a diagram where I have an angle, side, and then an angle. So that side, or these two angles are on either side of a side, so I can do like, it doesn't even have to match up perfectly, but it does help. So I can say these two sides, an angle, and then a side. So notice that the side has two angles on either side of it that are congruent. I should turn off the music. For side angle, which again, backwards is that word. It's a donkey. It's very funny, I know. If this would load, of course, I've been waiting it for, maybe I should refresh. Is that what helps? Go, computer. Side angle. So this one actually works half of the time, which means the answer over here is no. It has to work every time. And I'll show you why this only works half of the time. So if I zoom in here, notice that this triangle, I'm not really going to move around. I'm going to leave it like this triangle. There are two triangles that you can make, one that is congruent and one that's not congruent. Right away, that one is congruent. If I move this down a little bit further, right there, what's going on? Those two triangles are congruent, but check this out. If I swing this one all the way over here, I can make a triangle that looks like that or a triangle that looks like that, and of course I have to make this length shorter. Now the two triangles are not congruent. So the problem with side angle, or backwards donkey, it doesn't work half of the time, which means it's not good enough for us. We want a theorem, something that works every time. So that is why the answer is no. So the main thing to know here is that there are two options. One that works, one that does not. But side-side angle, the way that you would annotate it, you'd have two triangles where you'd have a side, another side, and then an angle. So a side, and then another side, and then an angle. That one does not work. And what you should have found was side, angle, side does work. And side, side, side also does work, and you can create the correct annotation. Side, angle, side. So I have some angle. Again, I'm thinking of that central angle. And then on either side of that angle, I have two of these congruent sides. So on either side of this angle, I have a side and a side that's congruent. On either side of this angle, I have a side and a side that are congruent.
What does that say? Above SSA.
It says ASS.
Can you please say it?
Angle, side, side.
No.
Oh, you want me to pronounce these? Asa.
No. NASA.
Oz. Like Jody Oz. And S. And Sass.
What other one?
Oh, yeah. Where? I don't see it.
The one on top of SSA.
Which one? Where?
Only.
Anyway, side, side, side also does work.
I want you to say it.
Side, side, side works. Side, side, side works. So those are how you annotate each of them. So these are the only tools that work. These four theorems, those are the only ones that are congruent theorems. Eventually, in the next unit, when we come back in January, I'm going to be talking about theorems that... Gunnar, can you please sit down? I'm like trying to teach and you're distracting a bunch of people. Eventually, I'm going to be talking about theorems that are for similarity, not just congruence. And that's going to unlock a few more theorems for us. But so far, we only have these four. Maybe put stars by them, celebrate them, put fireworks around them. There's only four theorems that work, and here they are. Nothing else will work. So come down here to example number 1. Are these two triangles congruent? Well, what is given to us? Are we given one angle, two angles, one side? What theorem essentially is trying to be provoked here? What theorem are they invoking? That's the right word. No, Pythagorean theorem is only for right triangles. That's a cool one. I heard it's created by a cool guy also.
No, not
Side,
really.
side, side.
Side, side, and that's it. There's no other side, right? Because they're only giving you two lengths. They're trying to invoke the side-side theorem. Is that one of the four theorems that you're allowed to use?
No.
No. So the answer here is no, because you only had a side and a side. Whatever they give you, that's the theorem that you're given. All right. Now the question is, what are you given this time? Obviously, you're given a side and two angles. Is it angle, side, angle? Is it angle, side, side? What theorem is this?
Angle, side, side.
No.
It's angle, angle, side.
This one is angle, angle, side, as Monse and Fernando both said. Because it goes an angle, then a side. Or you could do side, angle, angle. It doesn't matter. You can read them forwards or backwards. So we're talking about angle, angle, side, this theorem right here, which means that they are congruent. This is yes, and you can say it's true by angle, angle, side. Yes, for Monse and Fernando. This is what you're doing on the homework. You're taking what information they give you. Is it angle, angle, side? Is it angle, side, side? Which doesn't work. Side, side, angle does not work. Make sure that those four theorems are the only ones that work. You may begin on Khan Academy. Good luck.